Hello, my name is Jack.
My name is Tiko.
My name is Zimeng, and we represent 3 schools from California,
Nevada,
And Ohio.
In our research, we found about 3 to 5% of people have significant depth perception problems, and the risk increases with age. Falls are a major concern for older adults, where about 1 in 4 over 65 experience a fall each year, and vision loss makes these falls even more likely. Traditional aids like canes or guide dogs detect obstacles on the ground, but can't always sense stairs, drop-offs, or objects approaching from the side. Our project, WalkAware, helps people with partial or full vision loss stay safer. My grandma suffered a stroke and lost part of her vision and now struggles with stairs and uneven ground. To combat this, we built an AI model that detects when she approaches leads, helping her avoid falls, and added an ultrasonic sensor to catch objects from the side. Together, these features make walking safer and more confident for her and others like her.
We define a safe radius threshold around the user. Any objects entering this radius will trigger a voice and audio alert. Using the ultrasonic sensor, we can detect incoming objects from all directions. To demonstrate, I blindfolded myself and walked backwards towards the wall. As you can see in the radar map, the back wall is elevated slowly from a normal object to one within the safe radius threshold, and an audio beep is played. The same principle applies to all incoming objects from all directions. Rapidly spinning the sensor allows us to rapidly detect incoming objects from the left, right, front, and back. One major challenge was achieving fast, continuous rotation. Servos were too slow for rapid environment changes. We ended up with a stepper motor that achieves over 400 RPM and a slip ring for electrical contact in rotation. We designed 3D printed housings and axles to spin a standard slip ring with the motor. We mounted the assembly to a hat with a metal wireframe for support, along with a buzzer and speaker for audio alerts. A 16-strand wire carries signal to the main board, containing an ESP32 sense, ADXL accelerometer for fall detection, and a USB PD power module for portable power. We use the Arduino's multiple cores for multi-threading so the stepper gets consistent timing as the ultrasonic sensor has an invariable response time. A Hall effect sensor mounted at the base calibrates the stepper with a magnet mounted on the rotating platform.
The other part of the process is using an AI image recognition algorithm for detecting ledges, something that the radar is not able to cover on its own. This is a full layout of what it looks like. There is a 3D printed attachment and a clip that lets it hold on the shoes. The vibrator will be attached to the ankle. So this build type is really adaptable to any type of shoe that has laces it can clip onto. We chose the FOMO model designed by Edge Impulse, and compared to YOLO, it sacrifices some features like bounding boxes, accuracy, and the coordinates. To do the training, we created an Arduino script to automatically take pictures, and then a Python script to download these images and then upload it to the Edge Impulse Studio. Here's an example of how the model detects the spot with the highest confidence. Of course, we'd like to train the AI model more. Thanks to WalkAware, we'll be able to provide faster solutions to the walking canes and better detect not only ground obstacles, but also head obstacles.
With WalkAware, people with vision impairments won't be unaware of their surroundings or need to poke around, meaning that they can walk with confidence and potentially avoid falls.